Okay, so mostly what we're doing today is using the calculator to graph and solve. Okay, so there's a lot of calculator stuff to do. The homework completely depends on you using the calculator. So the sooner we get done, then the sooner you can just get to doing the homework, which is only like 7 problems. And once you know how to do it in the calculator, they're probably going to go really quickly. Right? So solving systems of equations by graphing with the calculator. So first what we're going to do is we're going to learn how to do it with the simple linear systems that we've been doing so far. And then we're going to jump forward to chapter 9 where we do the nonlinear systems, which is really the subject of this class, of this, it's the SOL. Anyways. Okay, so these are the steps. So first, in order to use the calculator to solve these equations, first you got to put them in the calculator. And you're going to put them in the calculator using the y equals button. So, of course, the equations have to be solved for y first, right? You have to solve them for y first. So you go to y equals, turn it on, go to y equals, and you're going to put the first equation, if there's just 2 equations, you put the first equation on the y1 line and put the second equation on the y2 line. Okay, then you're going to hit graph. Okay, graph button right there. It's just on the edge of my screen there. And you look for, again, what are we looking for that would be the solution to the system? An intersection point, right? So if you see the intersection point on the screen, then you just go second trace, right? Second trace 5 and enter, enter, enter. Simple steps. Right? Watch. Second trace, and you see the menu that's there? Number 5 says intersect. So it finds the intersection points of graphs. Now, how many remember doing this in Algebra 1? Some, but not all. I don't know what they were teaching you, but we're going to do what you did in Algebra 1 if you did it, but we're going to go well beyond that. We'll be doing things by the end of this class, which are no way anything you would have done before. Okay, if the intersection point is not on the screen, then you've got to zoom out so that it is. Sometimes it takes more than one zoom out, right? So zoom out, and then when you're sure you've got the intersection point on the screen, then you do second trace 5, enter, enter, enter. Right. So we're going to spend all the class just practicing on these things right here. Yeah. Sure. Doing okay? Look like it? Okay, so let's go ahead. So here's an example. And these two are already solved for y. So that makes it even easier. But, we're just trying to practice, the basic steps anyway, so that's good. So let me go up to my y1, negative 3x plus 2. 2x minus 3. Right, that was the first step. Second step? Graph. Right? Now, since these calculators were used before, like mine was used before, that's not normally what you see when you turn on the calculator and go to the graph. So you should know how to do this thing. How do you get the calculator to go back to the regular zoom, the regular resolution? Yeah. Yeah, zoom 6. So if you, like here, I'm going to do this because I don't like the way that looks. So if I go zoom, zoom is the middle button on the top, and 6. And now that's a little more like what I expect to see. That's usually what you see when you turn on the calculator. Zoom 6. So do you see an intersection point? Does everybody have the same graph? Okay. And there's clearly an intersection point, which means a solution to the system. Then you go right ahead with a second trace 5, enter, enter, enter. And what do you get? 1, -1, which looks about right. Okay, let me slow it down. Second trace 5. So the first time you hit enter, or when you hit 5, it's asking you the question, first curve? You know, it could be just as well saying first line. Is that the first line you're doing? It just said when we get into the nonlinear, they're not always straight lines. So they're called curves. So the more general term is to say curve. So it's saying first curve, and you can see that in the top left, it's got that first equation that we put at y1, and the cursor is actually blinking on that line. So at that point, you're almost always going to say, sure, that's good. And so you hit enter. And then what does it say? Enter. It says second curve. And notice it's changed. Now it's showing you what's on Y2, and it's blinking on the other line. And like say, if you're a simple linear system like this, you're for sure just going to say enter. And then it always says guess, question mark. And at that point, you're going to just say enter. And you get your -1 or 1, -1. Okay. Right, let's try another one. Okay. 5x plus 2. This is one we did in the homework the other day. Clear. 5x plus 2. Enter. 3x. And graph. Okay, does it look like there's an intersection point on the screen? Yeah, it looks like it's right there. So as long as you're convinced you got the intersection point, second trace 5. Enter, enter, enter. And it looks like the answer is -1, -3. Okay, so that was both of those problems. Both equations were already solved for y, so all you had to do was enter them in the calculator. Okay. So now let's see what happens if not. What if the intersection point is not on the calculator? You're going to zoom out. So now, when you put these in the calculator, y equals clear. You don't really need the fraction format to enter these in, okay? I mean, because you're only dividing by a 7. It's not like there's 2 factors or 2 terms or anything. So, I mean, you could just say -3x divided by 7 plus 13 divided by 7 without using the fraction format. But you really should know where the fraction format is. Right? When we start getting like more interested in the SOLs, this is the thing that's probably going to get, for some of you, it's going to make the difference between getting a problem right or not. You know, that you don't make a mistake with parentheses. So remember, if you want the fraction format, it's alpha y equals 1. So for -3/7 x, I'm going to put a negative, and then I'm going to go alpha y equals 1. And then I'll just enter the 3/7. 3 arrow down 7. And then I'll put the x. And then I'm going to go plus alpha y equals 1. 13, 7. Okay, for the next one, -1/3. Negative alpha y equals 1. That'll be 1 divided by 3. X minus 7 alpha y equals 1, 7/3. So before I hit the graph button, is this going to have an intersection point? I mean, just looking at the 2 equations, can you tell whether it's going to have an intersection point? How do you tell when you're looking at a system of equations whether two lines? The slopes aren't the same, right? As long as the slopes aren't the same, it's going to intersect somewhere. You know that that's true. What would it look like if they weren't going to have an intersection? They would have the same slope, right? Or if it's the same line, I mean, at this point, we wouldn't enter the same line on y1 and y2. I think we would know at that point that it's the same line. But now when I hit the graph, you know, there's one line, and there's the other line, and they're not intersecting. So again, if you don't, this is what happens if you try to find the solution when the intersection point is not on the screen. All right, second, trace 5, enter, enter, enter. And you get an error, right? It says no sign change. I'm not really sure why that's the error message, but in any case, that's not good. So now let's go back to our graph and zoom 3. And you have to hit enter before it actually zooms out. Zoom 3, enter. There's one line. There's another line. Does it look like the intersecting? I mean, to me it looks like it does, but what happens when I do the second trace 5? 1, 2, 3. I get the same error. So I need to go back to the graph again and zoom out one more time. Zoom 3. Now I'm really out in space, looking down on this. And now it pretty clearly looks like there's an intersection point in there somewhere. So go ahead, second trace 5, enter, enter, enter. And it should find the point. Looks like it's 44, negative 17. 44, negative 17. Is everybody able to see that? Again, how am I going to make me go back to the standard resolution? Because I don't want it to be zoomed out twice. Do a zoom 6. When you do zoom 6, you don't have to hit enter. It does it right away. You also don't actually have to say graph before you go to second trace 5. But if you do second trace 5, it's going to draw the graph. So you need to let it draw the graph before you hit enter, enter, enter. If you've already graphed it, then you don't have to worry about that. It's already on the screen. Okay. Oh, so this one they're not solved for y, right? So here's one thing. I'm going to show you this on the first equation, or actually I'll do it on the second equation, and just let you know, we're not looking to solve this thing for the purposes like you might have solved it for in any other class or anything. We just need to put it in the calculator. So, for example, in the second equation, if I'm solving this for y, what's the first thing I have to do for the second equation? Subtract 3x, right? So 4y, oops, edit, undo. I want blue. So I'm going to go 4y equals negative 3x plus 104. Okay, then what? Then I divide by 4. So y equals negative 3x plus 104 divided by 4. You don't need to simplify that. You could put that in the calculator just like that. There's no reason to simplify it. Again, you don't really have to use the fraction format. You could just do it like this, right? Y equals parentheses negative 3x plus 104 divided by 4. That's fine. You know, for our purposes, that's fine. So now you need to do the same thing for that equation and then put them in the calculator and see what you get. So let me put those in. First one, y equals parentheses, negative 3x plus divided by 4. Okay, then parentheses, negative 2x minus 38 parentheses divided by negative 5. All right, and we look at the graph at a normal zoom, zoom 6. And we can't see an intersection point, so we zoom out, zoom 3, enter. And now we do see the intersection point, so we go second, trace, 5, enter, enter, enter. And it's 16, 14. Is everybody able to get that? Easy stuff. The main thing you got to solve for y, right? You can do that, okay? Then you'll get these right. Okay, now we get into the linear quadratic. Okay. What kind of a function is this first one? Y equals x squared plus 7x plus 10. What do you call it when it starts with an x squared? It's a quadratic, right? What's the shape of a graph of a quadratic? It's a parabola, right? So we would know, in fact, this one, I could factor that. That would be x plus 2 times x plus 5, right? What are the zeros? Yeah, the zeros are negative 2 and negative 5. Is it opening up or down? Up, because that's a plus right there. It's opening up. So we know that if we were going to sketch the graph, 1, 2, 3, 4, 5, that it's something like this. Right? Now, y equals x plus 1, that's linear. So that's going to have a graph, which is y-intercept of 1. The slope is 1, so it would be something like that. Okay? But again, our ability to draw a quadratic accurately is not great, so we need to let the calculator do that. So go to y equals. Oh, I've got to get out of that. Y equals, clear, x squared plus 7x plus 10, clear, x plus 1. Normal zoom, zoom 6. Okay, so how many intersection points does it look like? It looks like it'd just be 1, right? So what's the most intersection points you could get from a straight line and a parabola? 2. I mean, if that was correct, we would have 2 right there. Right? This one doesn't quite look like that. There will be some time, maybe not this year, probably next year for sure, certainly in calculus, when you're looking at a graph like that and you really don't know that it isn't just like barely going over the edge and then having to go across again, that there is 2 crossings there. It's just you don't see them unless you zoom in. Before we do that, let's see if we can find one intersection point. Right? So if it's on the screen, then second trace 5, enter, enter, enter. Second trace 5. Enter, enter, enter. Okay, and it found an intersection point. Now this is something, I don't know if your calculator is doing the same thing. I've got a different emulator here. Is yours giving you all the 0.0000 and 0.00? Okay, well that's just the calculator not rounding off, right? What's the point there that it means to be saying here? -3, -2, right? So, I mean, if you can check that, put in -3, -3 plus 1 is -2. Do the same thing up there, it checks. You put in the 0.00001, it's not actually going to check. But that's just the problem with the calculator. Now, there is a way to zoom in and see that. Let me go to the graph. This is just a little bit of extra, right? If I go to that graph and I say zoom in, zoom to, enter, then this is what I see. And can I see the intersection point? No, you don't even see the intersection point. Let me go back to zoom 6. And I'm going to show you a way to zoom that most people don't know what it is, even though it's actually the first option in the zoom menu, right? The first option in the zoom menu says zoom box. So the zoom box allows you to like draw a rectangular box over the area you want to zoom in on and see what's there. So I've already hit that. If I use my cursor key, right, I move the cursor to where I want like one corner of that box to be. So for example, see my cursor on the screen there? So when I hit enter, it like anchors one corner of the rectangle. Now I'm going to move it to the opposite side and up. And then when I hit enter, it's going to zoom in on just that box. And at a zoom, at that level of zoom, it still looks like it's just one intersection point. So I'm done, right? That was the only point. But zoom box is a useful thing to have. Most people don't know what it's there for. You just keep going to the ones zoom in, zoom out, zoom 6. We'll do others. We'll end up doing zoom 9. And I think there's a zoom 0 that we do. What's zoom 0? Zoom, yeah, I've used that in the past and I don't even remember why now. Okay. Okay, so let's do this one, right? Y equals, already solved for y, so x squared minus 36, clear, x minus 16, and I hit the graph, and of course I'm still zoomed in on that box, so let me zoom 6 to get back to normal. So there's the parabola, and there's a line that just cut across the bottom. So what do I have to do? Zoom out. So zoom out. Zoom 3. Now I see the parabola, and I see the line. How many intersection points? 2, okay? So the point of this slide is, okay, when I do zoom, second trace 5, enter, 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 it's going to find a point. If I keep hitting that second trace 5, enter, 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 it's going to keep finding the same point. It's like, how do you find the other point, the one that it didn't just jump to? So let's find the first point by doing second trace 5, enter, enter, enter. And it looks like it jumped to the point on the left, -4, -20. Right, -4, -20. Okay, now, in order to get the other point, after we hit second trace 5, use the cursor key, the arrow keys, to move the cursor closer to the other point. Right, so second trace 5. And now when I hit right arrow, you can see the cursor moving along the parabola. And when you get it in the vicinity of the second intersection point, it doesn't have to be exact, just so it's closer to that point than the other. Then you hit enter, enter, enter. And it looks like 5, -11. Right, so when you've got more than one point to go after, you might have to use the cursor keys to get you to that other point. And you know, usually if you're talking about quadratics, yeah.
You also use Z-box around that intersection point.
The zoom box.
Yeah.
I mean, if you zoomed in on just that box there, then it would have to go to some point in the box. Yeah. Yeah. If you zoom into just that point and the other point isn't even on the screen, well, then it's got to go to the point which is on the screen. Okay. Okay, so try that one. Okay. I'm going to do it quickly, just so my video is complete. Y equals, clear. X squared minus 7x plus 14. Clear. 5x minus 6. Zoom 6. There's one, but there's only one intersection point, so I find that one easily. Second trace 5, enter, 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 and it looks like the 0.24. Then I go back, I say zoom out, and it's still, I'm not sure actually, you know, it looks so close, but it's like, why not just zoom out, you know? So zoom 3. I won't waste my time. But now it's kind of hard to see what's going on there, but I will second trace and then right arrow, 5, and then right arrow, see if I can see that cursor moving up. That looks pretty good. Enter, enter, enter. 1044. Okay. Okay, now look at this one. What's different about this one? You know, it's actually the y squared, not the x. What does a parabola look like if instead of being y equals x squared, it's x equals y squared? It is, you know, if I just look at the plain old y equals x squared and x equals y squared, those are inverses. You know, what do we know about the graphs of inverses? Yeah, they're flipped over the line y equals x, so they would look like that. Right? That's what x equals y squared looks like. It opens up to the right, not up. Right? So we still have to, if we're going to put this in the calculator, we have to solve for y. So this first one, to solve for y, I'm going to get y squared equals 7x minus 3. And then I've got to take the square root of both sides. So I'm going to get y equals plus or minus the square root of 7x minus 3. Right? The plus part is the top of the parabola. The minus part is the bottom of the parabola. You need both parts to put together a parabola which opens up to the right. At least in this coordinate system you do. So let's see. Let's go to our calculator. And do I got room? I think I got room. So let me go to y equals clear. Let me clear the second one first. And I'm going to put in the positive square root of 7x minus 3 goes on the first line. And then I'm going to put in the negative square root of 7x minus 3. Okay, together, that's the parabola. Okay, now I still need to put in this 2x minus y equals 3, because that'll be y equals 2x minus 3. So go to the calculator on line 3, you're going to put that in, 2x minus 3. Okay, now I'm going to zoom 6 to get me to a normal graph of this. There's the top of the parabola, there's the bottom of the parabola, and there's the line. Right? So how many intersection points do you see? Looks like there's 2, right? There's one with the top half of the parabola and there's one with the bottom half of the parabola. Okay, so they're on the screen, so we're going to go ahead. So second trace, 5 for intersect. Okay, now notice, before you go any farther, right, that it says first curve, and in the top left corner, it's got the square root, the positive square root, which is at y1, so that's why it picks that out. At this point, it doesn't have a y value. It has an x value, but it doesn't have a y value. So nothing's going to work until you get a y value for this. So right arrow so that it picks up a value here. Before you do anything, right arrow. Sometimes it takes one right arrow, sometimes it takes a few, but you got to make sure that your cursor is actually on. There you go. Now it's actually on that top half of the curve. Okay, so I can, for the first curve question, yes, enter. Okay, now it's switched and it's saying second curve, and the top, it's got the bottom half of the parabola. Is that what we want to be the curve that intersects with the top half? No, we want this line to be what intersects with the top half. So you need to down arrow so that it goes from y2 to y3. so that it's actually picking out. That's why, you know, it's not always that you just hit enter, enter, enter. Sometimes you got to pick the right thing. So hit second, enter. So now it's got the linear Y3 in the top left corner. So now I'm okay with that, and I hit enter. And if you're okay with the two selections you just made, then you hit enter, and it should find the top intersection point. Right, there we go, 4, 5. So we got 4, 5. Okay, now we got to do the other point, right? So second trace 5. Okay, now, do we want the top half of the parabola now? No, we really don't. We already found that intersection point. So I need to down arrow so that my first curve is actually the negative, the part of the parabola that's opening down. So enter. And then for the second curve, it actually already jumped to Y3, the linear, so that's good too. And if we're okay with that, we hit enter. 0.75, negative 1.5. Okay. That's good. Okay, so the last one was a parabola, because it was x equals y squared, a parabola that opened to the right. What kind of a shape is it that is x squared plus y squared? It has both squares. It's a circle, right? So this, you know, if you take a circle and you intersect it with a line, what's the most number of intersection points you can get? You can get 2. Could you get 1? It could be the tangent line, or you could have 0. So first you got to solve for y. So this is going to be y equals plus or minus the square root of 10 minus x squared. And the line is already solved for y, so that we don't have to worry about that one. So let's put that one in. Y equals. And I'm going to show you a different way to do the bottom half too. Some of you will catch on to this and actually like this better. So let's see, I'm going to put in the top half of the circle. Second, square root 10 minus x squared. Okay, now for the bottom half, I'm just going to say negative whatever I put on the first line, so I don't have to retype the first line. And sometimes the first line gets quite complicated. So this is how you do that. I put in negative, and then you see this key here that says vars, right? Hit vars, and then go over to y vars is on the top margin there. And the first option says function. When I hit that, and now we're on y1, so I hit 1. So on the second line now, it just says negative y1. I don't have to retype the whole thing. I just put in negative whatever's on line 1. Not necessarily, again, that's vars, y vars, 1. Okay, and then I still have to put in my straight line on the next one, 3x plus 10. And then I'm going to look at it. Ooh, top circle, bottom circle, straight line. Does that look like a circle? What does that look like? That looks like an ellipse, right? But it's not. It's just because they have the X grid is more spaced out than the Y grid. If you want to make it look like it's uniform, zoom 5, right? Zoom 5, which is zoom square. So that looks a little more like a circle than the first time did. Okay, do you see any intersection points on the screen? Yeah, I mean, it looks like there's, like I say, it's either 1 or if it's 2, they're like so close together that it's kind of hard to see at this resolution. Let's find the one that's obvious. Second trace 5. Okay, is it on the top of the curve that we need? Yeah, it is. It's blinking and it says Y1. Okay, enter. Is that what we want for the second curve? No, we need the straight line. So we're going to arrow down so that it jumps onto the straight line equation. And now, is it on the line? Yeah, it is. It's good. So I hit enter, enter. And it looks like it's 3-1, right? And again, what could I do to zoom in on that and be sure that that is? I could do a zoom 1. If I do zoom 2, we didn't get even on the screen. So let me try this again. Zoom 6. Zoom 6. And then let me drag a box. Zoom 1. Zoom 1. And I'm at 0, 0 now. Let me go over a little bit. Enter. Let me drag the other corner of the box. That looks like it should have it. Let's see whether it really looks like there's only one intersection point. And it does. So we're done. 3-1, there's your answer. Okay, so try that one. Solve for y, include the plus or minus. Right, so solve for y, plus or minus the square root of 1 minus 6x. The linear one is fine. You know what was good when I entered mine in here, because I had already put on the second line negative y1. I didn't have to put anything in there, right? That was already there. So the first line I replaced with the positive square root of 1 minus 6x. The second line was automatically the negative of that. And then the third line is our straight line. And you look at the graph, and you can see one intersection point, but it kind of looks like there's going to be another one. It's just not on the screen. So find the first one, second, trace, 5, enter, enter, enter. And it looks like 0.16, that's like 1/6. No, I did something wrong, watch. Second, trace, 5. So it's actually not on a graph because see there's no value for y. So I need to like left arrow so that it picks up a y value. Okay, now enter. Okay, do I want an intersection with the bottom half of the parabola? No, I need it with the straight line. Okay, now I'm on the straight line. Enter, enter. And negative 1.6, 3.2, negative 1.6, 3.2. Okay, next, zoom out, zoom 3, enter. And it's still with the top half of the parabola. Okay, it looks like it's intersecting. So second, trace, 5. Okay, that's good. Oh, I should arrow over so it's closer to where I think is the other intersection point. Come on. Okay, that looks good. Enter, enter. No, that's not right. Second, trace, 5. Enter, down arrow to get to the line. Enter, enter. Negative 22.9 and 11.8. Oh, I'm all over you. Negative 22.9, 11.8. I think that's right. Okay. So, ships. How many people have family that's on Navy ships? Anybody? All Air Force ship here. You know, the ships, their navigation system depends on finding the intersection points of hyperbolas, which are quadratics. Both of these are hyperbolas. I mean, that is really what's going on in the math behind. They used to have to do it all by hand, but now it's more computerized than that. But I mean, a fellow teacher of mine, somebody who got out of the military just the same time as me, and we were at Callahan, he said he remembered doing just this kind of thing. You know, to find their place at sea was to find an intersection point of hyperbolas. So it can be real world. So in this one it says, ship navigation systems work by finding the intersection of two hyperbolas defined by how long, not the how long, by how long. It takes radio signals to be received by 3 stations. See example 4 on page 660 for more details. In the end, we've got to find the intersection of the following hyperbolas. So what's the first thing I've got to do to find the intersection, to put them in the calculator? Solve for y. So I'm going to do this rather quickly. So if I move the y to the other side and then take the square root, this one's going to be y equals plus or minus the square root of x squared minus 16x plus 32. Okay, this one, if I move the x squared and the 8x, the negative 8x and the 8 to the other side, I'm going to get y equals plus or minus the square root of x squared plus 8x minus 8. So that's what I've got to put in the calculator. So here we go. Y equals, clear, I'm doing the one on the left, the square root of x squared minus 16x plus 32. Okay, the second line, I've already got the opposite of what's on y1, so that's good. The next one, clear. Second square root, and this one will be x squared plus 8x minus 8. That was a time. Minus 8. And again, on the next line, I'm just going to say, put in the opposite of whatever's on y3. So negative, then I'm going to go vars, y vars, 1 for function, and 3 for y3. That ought to do it. Now let's see what that graph looks like. Zoom 6. Okay, that's one branch of a hyperbola. It's kind of hard to see what's going on. Let's zoom out. First, do you see an intersection point? Do you see an intersection between the graphs there? I mean, there is. There's an intersection point here. They said x has to be greater than 0, so we almost don't care what's going on over here. But they said x is greater than 0. So there would be 1, and there would be 1 there. If I zoom out, maybe we can see the whole hyperbola. Zoom 3. Right? Okay, that's one hyperbola. And this is the other. So you've actually seen hyperbolas before. We graphed hyperbolas. Do you remember when we graphed something like that? And that's 2 of them right there. Remember when we graphed inverse variation? That's a hyperbola. It's got 2 branches. And that's exactly what you're looking at on the screen right there. It's 2 hyperbolas. So let's see. We don't care about what's going on for x less than 0, so let's go back to zoom 6. So we needed to intersect the 2 positive curves right here and the 2 negative curves right there to find those 2 points. So we might have to do some fiddling with, which is our first curve and which is our second curve. Let's try this. Second trace 5. And, okay, I'm on that one hyperbola. It's blinking on it. That's good. Enter. Okay, now it jumped down to the bottom. We don't want that, right? So now let me go down to y3. for the second curve. I think that's right, but I can't see it. Is that going to work? Oh, I'm not on a curve, that's why. Okay, now I'm on a curve. Now it's on that second one, right? The first one is blinking already, right there. That's this one. Now the other one is blinking there. Okay, that's the two that we want. And now we hit enter. Enter. And so that's blinking now, and the top intersection point looks like 1.6666. So it's 5/3 basically. And what does that say? 2.84? I'll call it 2.8. So 1.7, 2.8. Any guesses on what the second intersection point is going to be? How about negative? It's going to have to be 1.7, negative 2.8. Let's try that. So second trace 5. Okay, now we don't want the positive branch. We want the negative. So let's arrow down to get to Y2. And it is on there, so we get enter. And now we got a negative branch again. That's good. And we're good. And the intersection is 1.7, negative 2.8. All right. Okay, so last thing. If you know how to solve systems of equations with the calculator, the beauty of this is you can use that to solve any math equation. The most complicated math equation you can think of. You know, it could be logarithmic combined with trigonometric combined with exponentials and all that stuff all in one equation. But in the end, as long as it's like one thing on the expression on the left equals one expression on the right, you could turn that into a system and then use your calculator to solve it, right? I mean, including like technology enhanced items on the SOL, right, which we don't get right. Just do this, okay? This is how it works. So this is a polynomial equation. It's a quadratic equation that we actually would have solved back when we did quadratics very early on. So what you want to do is, in the calculator on the Y1, put the left-hand side of the equation, 24x squared plus 8x plus 2. And on Y2, put the right-hand side of the equation, 5 minus 6x. Right, that's going to be a parabola and a straight line. So now we're going to find the intersection point. And when we do, the x values will be the solutions to this equation. So let's go there. Clear. Y equals. Clear, 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 clear. So 24x squared plus 8x plus 2 and 5 minus 6x. And let me look at the graph, zoom 6. There's the parabola. And there's the straight line. Kind of, you know, it's very narrow parabola, but can you see how many intersection points it looks like? It does look like there's 2 on the screen. You know, if I could zoom in on that, I would zoom in on that. But so let's try to find let's find the first one, which it should find right away. Second trace 5. Enter, enter, enter. And it looks like the first point, 0.16666, you know, that is, you don't care about the y coordinate, right? There was not a y in that equation. We introduced the y because we turned it into a system. So all we care about is the x value. So x equals 0.16 repeating, which is actually 1/6. Okay, now we got to find the other. How am I going to find the second solution? Second trace 5, and what do I have to do to get the second one? move the cursor, right? It already found the one which had a positive x. It looked like there's one that has a negative x value. So let's left arrow until we see the cursor go up. There it is. It's almost there. Second curve. Good. Good. So negative 0.75. Right, which is negative 3/4. So there's your two answers. When you solve a quadratic equation, how many answers do you expect? 2. There we go. Okay, try this one, and then we're done. And hopefully you've learned more about the calculator than you ever thought you would know.
So what do we do if we can't finish that homework?
Right, one of the graphs looked like that. The other one looked like that. So no solution. So the homework is, the whole point of the homework is to use the calculator here. Now we only have like 15 minutes left. And there's only, how many? 8 problems, which you might get done. If you don't get done, then we'll start class next time and you'll get them done then. Okay. These here, going back to page 264, those are, polynomial equations to solve. So just let's try to do them not like we did back then, but by using, turn it into a system and find the intersection point. Yeah, how many have a calculator at home? Most. If you don't, I think, how many log into Citrix at home? And they have a calculator that you can always use. But still, if you don't get it done, we'll spend a little bit of time doing it in class.